Welcome to our factoring lesson. Get your title page written down, your learning target, and your I can statement, and then get ready to go.
All right, we're starting off today with reviewing the greatest common factor. That was in our last unit. We are going to review with factor trees as well as factor rainbows, and our problem is the greatest common factor of 30 and 12.
So which way are you going to do first?
Whatever you want. I was waiting for you to set it up. Make the decision.
Let's do some
me.
factor trees first.
All right. So 3 times 10?
I was going to go with 10 times 6, or 5 times 6. But
okay, if you just want to do the problem, go for it. 2 times 5. So circle in. I don't know if you're rewriting.
You rewrite it, I don't
3
bother.
times 4. 2 times 2. So they have 1, 3 in common. Are we doing that part now? 1,
I was just
3
going to
in
do it in
common.
different colors.
Okay. 1, 2 in common. And 3 times 2 is 6.
So that's one way to do it. The other way to do it is with our, Mrs. King called it the rainbow method, your little rainbow factors.
Sticking with Romanovich, that's what he calls it too, I think. So what times what is 30? So we're going to go with 1 times 30, 2 times 15, 3 times 10, and 5 times 6.
Just enough room in there.
1 times 12.
Sure, you can just do everything. I can just be the
2 times
guy who
6.
writes.
And 3 times 4. Greatest common factor then would circle the 6 on both lists.
So whichever method you're more comfortable with is fine. As we get to some of the problems, if you can just look at the two numbers and know what's the largest number that goes into both of them, that's fine as well. But here's what we're going to use it for. Factoring an expression is basically pulling out the factor that they both had in common. Think of it as the distributive property in reverse.
Get that sentence down.
So we're going to look at 14 and 28 and think about what do both 14 and 28 have in common, or what's the greatest number they have in common. So I'll list out my factors real quick. I have a 1, a 2, a 7, and a 14. For 28, I can do a 1 and a 28. I can do a 2 and a 14. I can do a 4 and a 7. So my greatest common factor is the largest factor in both lists, which is my 14. So basically think of, we're going to pull a 14 out of each of these two numbers. We're going to divide them both by 14. 14 divided by 14 is 1. So this really breaks into a 14 times 1. 14 times 2 gives me 28. So basically I divided them both by 14. I pulled the 14 out, and now I'm left with whatever was left over. And then this is where it becomes the distributive property in reverse. We're going to take the numbers in the parentheses. That 14 is going to get pulled out to the front. What was left in the parentheses stays in the parentheses. So it becomes 14 times the quantity 1 plus 2. We divide out that common factor and leave the leftovers inside.
So you could use the distributive property to check your work. All right, so we're doing another problem. So we're looking at the greatest common factor of 80 and 56. Are you going to use the factor tree? You better, because 80 and 56 are pretty high to find the greatest common factor.
I'm going to wait until whatever you did.
8 times 10. There's no way they'd get all of them.
I'm pretty sure it's going to be 8, but we'll double check.
2 times 4. Oh, did you just want to declare it 8 without proving it?
No, we should probably double check just in case I'm wrong, like I was in the last video.
2 times 5.
So I have a 2, a 2, a 2, a 2, and a 5. I'm assuming you're going to go with 7 and 8.
I was going to do 7 and 8. 2 times 4, 2 times 2. So what is that? 2 to the 3rd power? All right.
So we have
a
2, a 2, and another 2. They each had 3 2's in common, so that means their greatest common factor is 8.
So we're going to pull that 8 out. Set up the parentheses. Now what number multiplies 8 to get 80? So we would put 10 in the parentheses, and 8 times 7 would get the product 56. So the 8 is coming on the outside, setting up the distributive property.
So that common factor
out that 8.
Is what comes out front.
And then what's inside the parentheses is what remains 10 plus 7. So if we were to distribute 8 times 10 would give us 80.
That's exactly what I was going to say.
Really? And 8 times 7 would give us 56, so we know we've done it correctly.
Of course, I would show my work in here of 8 times 10, and then the 8
There's
times...
no way they'd be doing that to check
7.
their work. Give me a break.
Okay.
All right.
Next one, now we're going to try the same thing, except a variable is in here. Nothing is different in how we tackle the problem. The variable just goes along for the ride, just like when we multiply and there's a variable involved. So we want to look at both 18x and 9 and figure out what's the largest number they can both be divided by. Hopefully, if you can think about it, 9 is the largest number that goes into 18 and into 9. If you're not sure, you can list out your factors or your factor trees, but I feel comfortable that our greatest common factor is going to be 9. So that's the number that we're going to pull out from each one of our terms. So think about, if I had 18, what would I multiply times 9 to get back to that 18x? Well, I have to multiply by 2.
I like it in a different color, please.
And the x goes along for a ride. Quit being critical. What would I multiply times 9 to get back to 9? Well, 9 times 1. I'll switch colors just to make it more colorful.
You.
Now we pull that common factor out front, our 9, and whatever's left in the parentheses is what stays in our parentheses. But you absolutely, positively must show us this step in the problem before you can jump down here.
We saw all of you trying to skip that step in the distributive property as well, so don't do it.
Last 2. Let's try a couple more.
All right.
I apologize in advance if her writing is horrible.
So I'm looking at the 11 and I'm looking at the 55 and I'm trying to figure out what the greatest common factor for both of them are. If you feel
That spells GCF if you can't read it.
If you feel confident in declaring it 11, go for it. If you need to list it or do your rainbows, that is your strategy. So 11.
She's being very careful now to... No, you took it. You keep writing. So now you're going to turn each one of these terms into 11 times something that would get us back to that original term. So we're kind of dividing out that 11 and trying to see what's left over. So from 11x, if I divided out 11, I would just be left with 1x. And a good way to check is do 11 times 1 would give us right back to that 11x. For our next one, to get from 11 to 55, I would have had to multiply times 5. So that's my missing piece. We take that common factor of 11 and pull it out front.
It changes colors on this part.
I would have gone with purple, but that's all right.
I love red.
I know you do. The 11 comes out front, and then whatever's left in the parentheses stays in the parentheses. So we are left with 11 times the quantity, 1x plus 5.
Yes, it is okay to write 11 times x plus 5.
That's a nice fancy x there at the end. All right, last one. 63 over there.
All right, we're good.
All right, 63 plus 81y. So you got to look at both 63 and 81 and try to figure out what can go into both of those numbers. If you think about it, they're both factors or both multiples of 9, and I can't think of anything larger that can go into both of those numbers. But again, you could list out your factors, or you could do your factor trees to make sure. But we're going to divide a 9 out of each of them. So ask yourself, what would I multiply times 9 to get back to that 63? Well, that would give me 7. What would I multiply times 9 to get back to 81y? Well, 9 times 9 gives me 81, and the y just comes along for a ride. So don't lose the variable in the problem.
Oh boy.
What color do you want now?
Purple. You get mad.
All right. So now we're going to take that. You got to keep the pen close enough to the board. So now you pull that common factor out front. That's our 9. Whatever's left inside the parentheses, our 7 and our 9y, are what stay inside the parentheses. And again, a very quick check is just multiply back out using your distributive property. 9 times 7 is 63. 9 times 9y is 81y.
Oh boy, I'm using a time sign. My kids will get mad.
That is pretty bad. I wouldn't have done that.
Whatever.
All right, have a good day.
Hopefully they shut it off by then.